Before we go on, ladies and gentlemen, can I just very briefly ask you all to stand up, please? Could I just ask you to stand up? And now, could I just ask you to sit down back again? Thank you. There is no purpose in that. I was just checking if you're paying attention. So my question before we move on is, do you or did you watch Dr. House, MD, or Grey's Anatomy? Show of hands. One of the most interesting things that they do or did there was what they called an exploratory surgery. It's like they perform a surgery on somebody and they don't know what they're looking for. So this myth of exploratory testing seemed very interesting to myself anyway. You already know Rex, who was our speaker this morning, but for those who came later, just a very brief reminder that Rex Black has 35 years of software and systems engineering experience, and he is president of his own company, RBCS. In the morning, he was talking about non-GUI test automation, this time about myths of exploratory testing. Let's have a big hand for Rex Black.
All right. Thank you. Thank you. Is this working? Sounds like it. Okay, very good. So, you may not be familiar with these two or three people, excuse me, on the picture here. But then again, you might be, because I was sure you would have no idea what defenestrate meant. And then I found out that the word actually derives from some sort of famous Polish historical incident when some priest was thrown out of a window. So defenestrate apparently is actually like a word that's derived from Polish origin. So who knew that I was using the right term in the right place? But anyway, these three people are famous explorers of the United States. That's Lewis and Clark being the two, and Sacagawea being the Native American woman up there. And she was the one who actually knew where they were going, right? She's the one pointing things out, just to explain the picture, because you might be looking at it going, what is that all about? Okay, so what I'm going to talk about here is exploratory testing and some myths around it, and what it can do for us as well. So I'm guessing that all of you are familiar with this term, exploratory testing. Yeah? And it's probably something that you've all done to a greater or lesser extent. So let's dispel a few myths and then talk about what it actually can do for us. So broadly speaking, we can say that there's a category of test design techniques called experience-based test design techniques, which are basically any time that your primary test basis, in other words, what you're deriving your tests from, and your primary test oracle, which again is the oracle is the thing that you're consulting to determine the expected result of the test. When your primary test basis, your primary test oracle are your skills, knowledge, and experience, then you're doing an experience-based test. Now you might be thinking, isn't all experience-based testing exploratory testing? No, not necessarily, because I could have a checklist that I've accumulated over years of important things to try. It's effectively a list of test conditions, and I could have within each one of those items on the checklist a logical test case or how I'm supposed to try that particular thing. And so that is effectively a pre-designed test, right? And it's experience-based because the checklist grew out of my experience. But if the testing is investigatory, like the exploratory surgery that you mentioned, like I don't know exactly where I'm going to end up, I don't know exactly what I'm going to test, and it ends up being kind of a non-linear exploration of the system, then that's an exploratory test, and it's typically done based on experience, skills, and intuition. So hopefully the distinction there is clear that exploratory testing is a subset of experience-based testing. Now, a survey a couple years ago looked at different techniques that are used, test design techniques, And 2/3 of test teams in that survey said that they used exploratory testing, which was the second highest. The only thing higher than that was use cases. 70% of testers in that survey reported that they used use cases for test design. Now, that's interesting and potentially horrifying, at least to someone like me, because I would have hoped that the percentages for a lot of the other structured techniques like decision tables and state diagrams and domain analysis and so forth would have ranked a lot higher than they did. So I'm not saying that exploratory testing is bad and that the number should be lower. In other words, less than 66% of testers should use it. In fact, I would say that 100% of testers should use exploratory testing. But I'd also like to see 100% of testers able to do boundary value analysis, equivalence partitioning, domain analysis, those kinds of things, and I'm afraid we're not quite there. Now, I'm going to talk more about this a little bit later, but it's important to remember that exploratory testing, since it's based on our own experience, skills, and intuition, is a form of validation. It's not based on a specification. You're testing based on a specification, and that's verification. Checking that you built the thing that you intended to build. But validation is about checking to make sure that the thing that you built actually solves the problem that the customers and users need it to solve. So that'll come up again a little later, and it's an important thing to keep in mind that validation and verification are both important aspects of testing. So let's start with the myth busting. So there's the origin myth of where did exploratory testing come from, and people will sometimes point at Kahner's book, Kem Kahner's book, Testing Computer Software, and say, that's the origin of exploratory testing. Silicon Valley, specifically games development, electronic arts, that background. Well, no, I don't think so. I'm pretty sure that the first person to ever do exploratory testing was the first person to ever write a program. That there's some element of that in just developing software that you end up just kind of playing around with it and seeing what it does, even when it's your own software. Now, if you think about the book Mythical Man Month by Fred Brooks, in that book is the first published reference to independent test teams. And Fred Brooks, the book was published in the 1970s. Brooks was talking about the work that he did at IBM in the 1960s. Okay, so that goes way back. Now you could say, where was this first described in some written form? Well, Glenford Meyer's book, The Art of Software Testing, describes error guessing, which if you look at it, you realize, oh yeah, that's a form of exploratory testing. Okay, so this is a very old technique, at least 1960s. I would say probably more like the 50s or 40s. So, one myth debunked. Now, how about the completeness myth? Now, some of you may have heard this before as a charter for a test team, especially if you're the lone tester in an organization. And you may go around and ask people, hey, what do you think I do? Which is a good exercise, by the way. If you're the only tester in an organization, go around and ask your colleagues, what do you think I do? Some of them will say, I have no idea what you do, which is bad, because if you have a stakeholder who doesn't know what you do, ask yourself whether you think that stakeholder believes that you add value. Probably not. Yeah. But an answer that you're very likely to get in small organizations that have just one person doing the testing, and they haven't really thought much about testing, they don't know much about testing, is they think that you just play around with the software and make sure that that it works before it can be shipped. You're like, you sit down and you go, it's fine, ship it. So this happens. A lot of organizations do this. And of course, the testers that are in that role are very familiar with a question. That question is about bugs that are found in production. How come you didn't find that when you tested the software? How many of you had heard that question? Hey, how come you missed that bug? How come you didn't find? Yeah, see, a lot of you. And the rest of you, you don't have your hands up. You just have a sprained shoulder or something. You can't raise your arm. Everybody who's ever been a tester for any length of time has heard that, right? Been in some sort of organization where the expectation is that you are like just, capable of finding all bugs, unless, of course, you're just being lazy. Yeah. So eventually, organizations realize that actually that can't happen. That you can't just sit around and just play with the software a little bit and find all the bugs. And so the myth dispels itself. But unfortunately, what happens is that the myth keeps popping up, and it's something that we have to remember. Is that as an industry, we are still not very good at evolving forward. We don't do a real good job of building on each other's mistakes and evolving as a actual form of engineering. We spend a lot of time going in circles. So what happens is that while one organization learns that just some person sitting in a corner doing exploratory testing for 4 hours is not enough to get adequately tested software into production, and that organization learns that, along comes another organization that has yet to learn that, and for some reason that knowledge doesn't get transferred. So we would really need to have better testing education in computer science courses, software engineering courses, and we would also need to have standards for how, minimal educational standards for people getting jobs in IT, so that we could know that everybody knew that this was a myth. And that would be the only way of stamping it out. I mean, if the medical profession were the way that software engineering is right now, you'd still have doctors coming into practice as doctors that would think that cutting someone's arm open and letting 3 liters of blood out of their arm was a good way to treat them for a severe fever. And that used to happen, right? 200 years ago or so, that was like, yeah, these good bad humors in your blood, so we're just going to let some of it out, right? And that's sort of where we are in software engineering. Now you might say, well, yeah, okay, one person who knows nothing about what they're doing, can't do an adequate job with exploratory testing, but surely if somebody has been trained by some mighty Jedi Knight of exploratory testing, I understand one of them is visiting Europe, and the next few days will be this mighty Jedi Knight of exploratory testing out. That person will then, being kind of mini Jedi, be able to find all the bugs that matter. So it may not be complete, but we can find all the bugs that matter. Sadly, for that theory, facts will not comport with that. So Microsoft did a study where this is one of the things that you get to do when you have huge companies. They basically put their test team, divided their test team in 2, and one group was only doing exploratory testing and other forms of reactive testing. In other words, no pre-designed tests. And the other group was doing entirely pre-designed tests. And what they found was that they found different sets of bugs, these 2 groups. Overlapping for sure, but only partially overlapping. So it wasn't like the people doing the pre-designed tests found all the bugs that the exploratory testers found and then some, or vice versa. It was that each team found a number of bugs that were found by the other team, but also each team found bugs that were not found by the other team. Okay? So really, this idea that there's some sort of magic technique really is something that comes back and haunts us over and over again in software engineering and in testing. This idea that if only we could all just do X, that would be enough, right? We see it over and over again. We got this promise about 20 years ago, really in the last 10 years it came to the fore. If only we were all developing software using agile methods, everything would be great. Yeah? Or 30, 40 years ago, if only everybody was developing software using object-oriented programming languages, everything will be great. See, we have this problem. We go after the bright, shiny object a lot. Oh, this is going to be the one solution. That's not the way of thinking about it. A better way of thinking about testing is like a water filtration system. Okay? You see the little fancy GIF up there? Shows how you take lake water and turn it into drinking water. There's not one step. It's not like one place somebody goes up and hits the water with a magic wand and bang, all the sticks and dirt and bugs and viruses and bacteria fly out of it, right? That's not what happens. What happens is every step along the way there, something's being done to transform the water from less potable to more potable, right? And that's really what we have to remember, is that there is no one test strategy that's going to get you to 100% defect detection effectiveness. But if you have a whole sequence of things, starting with static testing of requirements or use cases or user stories or whatever you're doing, you know, unit testing, static code analysis, integration tests, system tests, right? Each step along the way removes some percentage of the bugs, and by the end, it's very good. But you just say, with this one thing, we just do this, no. And sometimes you run into the opposite assumption. Well, you know, we're doing test-driven development, acceptance test-driven development, behavior-driven development, so we can have 100% confidence. The software does everything we said it was going to do. It's completely conformant with the user story or whatever the requirement is. Yeah? So this is kind of the flip side of the myth I was just talking about. This is the irrelevance myth, that exploratory testing and those other kinds of testing, they have no relevance. As long as we verify that the software does exactly what we said it was going to do, boom, done. Yeah, very common. I mean, most of the time, if you go and you hire an outside vendor to develop software for your organization, and you ask them, did you test it? And they say yes, it's a pretty safe bet that all they did was verify that it does exactly what the requirements in the statement of work said it was going to do. Right? Because why would they do anything more? Because to them, they're looking at that, they're saying, hey, that's the contract, right? Which is a reasonable position, I suppose, for an outside vendor to take, but when you're testing your own software, is that the right way to think about it? Are you trying to just build software that meets its specifications, or are you trying to also build software that does what the user needs it to do? Are you trying to do both? Right? These are the classic definitions of quality. You've got Crosby's definition of quality as conformance to requirements versus Duran's definition of quality as fitness for use. And they're complementary, and you have to think about both of those, right? So the Agile quadrants is a good way of remembering this, if you prefer that to purely thinking about balance of verification and validation. You know, if you look at quadrant 1 and quadrant 2 stuff, that's verification, because that's deriving from the requirements of some sort, right? The quadrant 3 and 4 stuff, that's validation. Now, it's true that Merrick didn't call it that when he came up with the quadrants, but if you think about support the team, you look at what he's talking about in terms of what supports the team, those verification types of tests. And validation, evaluation of the product, that's validation. Okay? So even if you're not doing Agile, you can use this model. And basically, exploratory testing fits right smack into quadrant 3. Okay? That's where the exploratory testing would fit. It's business-oriented validation. And you've got to do some of that. You've got to do some of all of the quadrants. Okay. Now, another thing that you'll sometimes run into with organizations that have done exploratory testing and maybe gave it up was it's unmanageable. You turn people loose, and they go off, and they wander around in the software for a while, and they come back and they say, I like it, or they come back and they say, it sucks. And then you say, well, what did you actually cover? They're like, no, I don't know, whatever occurred to me. And then if you have like 10 people doing exploratory testing on the same thing at once, common complaint is, yeah, but they're just all kind of wandering around and bumping into each other and covering the same things. Which can happen, but doesn't have to happen. Right? The myth here is not that doesn't happen, it does happen. And the myth is that that's unavoidable. And it is, in fact, quite avoidable. There are various ways of logging what was covered. So there's a tool called Rapid Reporter, for example, which is open source, and I have no connection with it other than I have seen it used before, which is a nice way of capturing what you covered and notes about what you saw while you were covering it. What should be escalated to the appropriate people. What did you see that was weird? What kind of data did you use? Screenshots and so forth, right? So what you can do if you want to have this traceability of your tests back to your test basis, whatever it is, your test basis elements is, you capture the details of what you tested using a tool like this while you're doing exploratory testing, pop it into whatever your test management tool is, and quickly link it back from a coverage point of view to whatever it covers. So you can have exactly the same kind of coverage information and traceability detail with your exploratory tests as you would have with a pre-designed test. It's just that that information is captured after the test is run, not while the test is being written. Right? Now you might say, okay, well that solves the coverage part of the problem, but what about the management part of the problem? How do I deal with this, I got this herd of people wandering around in the product and they're all bumping into each other and testing the same things. Isn't that going to be inefficient? Well, no, you can use what are called test charters, which are basically like that checklist that I was talking about before, but it doesn't have any details about how to do the test. It just has test conditions. Cover this, cover this, cover this, cover this. And then you give each of your exploratory testers one of the test conditions in the form of a test charter, and you give that person a set amount of time to run the test. 15 minutes, an hour, 2 hours maybe for really extensive conditions. And then I can make sure that people aren't bumping into each other and covering the same things because I've set them off in specific directions. Now, might there be a little bit of overlap? There might be, little, when you have related test conditions. That might not be a bad thing because that gives independent perspective too. To the extent that there's a little bit of overlap, if you see two people went into the same area of the product from different directions, as it were, one of them saw problems, the other one didn't, you might say, guess it depends on how you look at it. But it's definitely manageable. So, those are the myths dispelled. Now, exploratory testing is a part of experience-based testing. It's a type of experience-based testing technique. But in addition to techniques, we also have testing strategies. Now, I'm not going to go off and talk about all the different strategies. There's a recorded webinar on different testing strategies that you can find out on the RBCS YouTube channel and also on our website if you want to give that a listen. But one type of strategy, testing strategy, is called a reactive testing strategy. And basically a reactive testing strategy is a testing strategy where we react to the software that was actually delivered to us rather than try to pre-design tests that are going to adequately cover it. Okay? That's what reactive is. We are reacting to what was actually delivered to us. Now, if you were given a perfect set of requirements that entirely described the way the software was going to work, theoretically you wouldn't need reactive testing. Okay? Now, have any of you ever seen a perfect requirement specification? No, I didn't think so. No hands go up. Yeah. They're never perfect, right? They're always incomplete, and to the extent that they do specify things, there's usually problems in them. Yeah? Now, if you're in an agile type of environment, which a lot of you I'm sure are, there's an emphasis on limiting documentation, which in a lot of agile implementations gets translated into, yay, we don't have to write anything down, right? I'm sure some of you are dealing with that. Yeah, agile means I don't have to write requirements. Agile means I don't have to write anything down. I could go off on myths of what agile doesn't actually mean, but people think it does as well, but that'd be a different presentation. And of course, in agile projects, you have a lot of ongoing change. So both of those are things that are going to make reactive testing even more useful. But remember, no one strategy by itself is going to be the magic wand that drives all the bugs out of the software. It just doesn't exist. It's a series of filters, not a single shield. So what you want to do is use other types of strategies. Risk-based testing, requirements-based testing, regression-averse testing that involves heavy use of automation if you can. Ideally not entirely through the GUI, as I discussed this morning. So in terms of doing your exploratory testing, as I said, having those charters is good. Well, where did the charters come from? Well, during the analysis stage of the testing process, which would happen pretty much in parallel with the definition of the requirements, for example, during iteration planning in agile type of life cycle, we're going to come up with our test conditions. And remember, the test condition is a thing that we want to test. It's not how we're going to test it. The how we're going to test it is the test case. The thing we want to test is the test condition. Right? So for example, make a successful purchase with a supported credit card would be a test condition for an e-commerce application. Right? That doesn't say how to test it. That just says this is something we need to test. So I take those test conditions and I break those test conditions up, assign them to test charters, assign a certain amount of time, and then, of course, when the tester goes to run the test, their design and execution will occur at the same time, rather than the test being pre-designed prior to execution. Now, can you use formal test techniques, black box test techniques, white box test techniques, in combination with exploratory tests? Sure, why not? And sometimes people ask me if I'm doing a training course, they'll give me some hypothetical and they'll go, is that black box or is it white box? Or is it exploratory? Try to put this thing into a clear category. And when they do that, I generally quote the very wise software testing expert from China, Deng Xiaoping. Deng Xiaoping and his cat. Deng Xiaoping said, who cares whether the cat is white or black? All we care is that the cat catches mice. No, not familiar with that? No, okay, so Deng Xiaoping actually was not a famous software tester. He was a famous communist who wasn't really a communist because he was the communist that decided that China didn't actually have to be communist. And he was the one that introduced all the market reforms. And his comment about we don't care whether the cat is black or white was directed at Maoist absolutists who, when he was suggesting introducing market forces in China, they were saying, no, that's not communism. And his response was, don't care whether the cat is white or black, you care that it catches mice. Okay, same thing here. We don't care whether the test is white box or black box. We care that it catches bugs. Okay? We don't care whether it's exploratory or not exploratory. We care that it catches bugs. So don't get all caught up in this, taxonomy and ism stuff about, am I doing this? I'm doing that. We waste a lot of time in software testing having these kinds of silly arguments. Don't worry about it. Do what works. Okay, so let's focus in on, exploratory testing, like what do these sessions look like? So I've got my charter, which again is part of that's the test condition. There can be other things that I'll get into in just a moment. And it's time boxed. So I've got 15 minutes, 60 minutes, 90 minutes, whatever, to cover that. And that prevents overlap, and that prevents the runaway tester problem. The testers just kind of scattering or bumping into each other, getting off and testing a bunch of other stuff. So that time box, that 15 minutes, 90 minutes, whatever, that's supposed to be all of the activities that are associated with running that test, though in some cases, in a lot of cases, the creation and loading of test data and the configuration of test environments will actually happen first, because otherwise you'd spend all your time creating test data and setting up test environments. Now, what are you going to do in that session? Well, kind of depends, because it's exploratory. Right? Some of it's just kind of basic looking around, and certainly it's going to be evaluating the thing that you're testing. Does it work? Does it accept supported credit cards, right? Can I actually make a purchase with all the supported credit cards? Of course, I'd have to know what the supported credit cards are, right? And I'd have to make sure I checked each one of them. Yeah? Now, there might be a situation where I want to go deep. So with the supported credit card example, do those work everywhere? Like I've noticed that here in Poland, anytime I go to pay with a credit card, I try the American Express card, most of the time it doesn't work. Give them the MasterCard, it works, right? So, deep coverage might be, what are all the different circumstances where I could use the different cards, and let me try all the different possibilities of that, right? But you have to think about risk here too. Where does it, from a risk point of view, does it make sense to actually go into great depth? One of the things that can go wrong with exploratory testing is that somebody gets fixated on some loose thread on the sweater, basically, and they just kind of go down this rabbit hole, test something really, really deeply, and not go broad. So this is where you're relying on the skills and experience of the tester to not get distracted by the bright, shiny object, but instead to say, from a risk point of view, what do I need to focus on here, right? And it is really critical that you have people that have adequate experience doing this, which is kind of a duh, because it's an experience-based testing technique. So, I was talking about this with one of my clients, and they're like, oh yeah, we like that. Yeah, it's got to be experience-based. But we also have space, they said, for ignorance-based testing. Right? So testing by people that don't know what they're doing. And that absolutely makes sense in some situations, right? Like certain kinds of usability evaluations, you definitely want to make sure that you've got somebody who's got no clue doing the testing, right? But, God help you if you're doing all your exploratory testing, but it's actually ignorance-based testing, because the kinds of reports that you get back from that are mythic in their lack of usefulness. Now, I mentioned that the charter would talk about the condition to be covered, and that's certainly the case, right? That's the purpose of the test. You can put other material in there too, like who's the intended user, different suggested user personas, role-based security implications around that, what's the relative priority so that we know which charters to start with, which ones to end with. If there's reference to, say, test basis or test oracles, you might put that in there. Of course, data that's been created, different variations to try, different suggested actions or activities. You can put more and more detail into these charters, but the thing to remember is the more detail you put into the charters, the more you are constraining the testing that will be done. And now you're moving away from it being an exploratory test to being more of a pre-designed logical type of test. Now, while you're off roaming around doing your exploring, as I said, it's really important to not get distracted and end up spending all of your time in one particular area and then look up and go, oh no, I've squandered my testing time on one little piece and I need to go broader. So what can help with that? Well, keep an eye on what is most important. What do I need to look at? Obviously, if you get hot on the track of some major bug, you don't want to just say, oh, I'm going to stop investigating this bug because if I investigate this bug, it's not going to leave me time to test the other things, right? Got to keep our eyes on the priority here, of course. But you know, if we're just running tests and we're not finding something, we need to make sure that we're going broadly enough. Think about what's likely to fail. Well, where's the system going to be weak? Try to think of weird ways of using it, doing things in different order, interruptions, especially with mobile apps. What happens if the phone rings when I'm in the middle of doing X, right? Whatever that X is. What happens if I get a Twitter alert while I'm in the middle of doing X? Yeah. What happens if the battery starts to get low and I get into a low power mode? Again, remember, this is about validation. Your perspective while you're looking at this should be not, is this what the requirements say? But rather, is this what the customer or user would want? If I were the customer or user, how would I feel about this? And beware of acclimatization. Acclimatization happens when testers have seen the same kinds of failures over and over again. So like, oh yeah, it always does that. Well, maybe so, but it's always wrong when it does that, right? Don't get acclimatized. This happens really quickly. Sometimes people say, well, the testers really shouldn't know a whole lot about the implementation of the software because if they understand how it works, they'll rationalize away the failures. But that's actually not why people get acclimatized. People get acclimatized to things just because that's basic human nature. We get acclimatized to things. People can get used to all sorts of things, right? As a tester, you have to remember, don't get acclimatized. And if you're a test manager, you got to remind your testers, don't get acclimatized. You got to constantly think, well, what is the user going to want? What was the user going to expect if you're doing exploratory tests? Don't forget about installations, upgrades, uninstalls, those are the sort of things. Because we have to do those, right? The users have to do them. It's really easy to leave those out of your set of test charters, but you know, problems with installations, upgrades, and so forth, these are very, very demotivating and irritating to end users. If you're doing mobile apps, for example, somebody has a problem, they can't install your app or it, you know, an update downloads and now the app doesn't work anymore, what's going to happen? Bing, uninstall, bing, 1-star review on the App Store, bing, I just downloaded your competitor, right? That happens, you know, a few times and now, you know, your mobile app development company is now no longer a mobile app development company. It's a former mobile app development company that is now bankrupt. Yeah. So, you know, there's this thought of this phrase that has migrated around the world of fast failure, like, you know, just put it out there. If it doesn't work, it's fine. We'll fix it. We'll spray out a new update. No, you can't unring a bell. Okay, once you've given somebody a bad experience with the quality of your product, they've had that bad experience, right? Now, what kind of ideas can we use to do our exploratory testing? Hey, any source is good. What do you know about the system? What do you know about the problem it's supposed to solve? What do you know about how people use your software? What do you know about the ways that your software fails? And you might say, well, we're developing this new thing. Well, if it's a brand new thing and nobody's ever done it before, yeah, that's kind of an issue. But if it's something that is similar to things that have been done by other people before, go do some reading on it. Read about ways similar software has failed. Explore boundaries. If your application works with data, CRUD is a good acronym to remember. Create data, read data, update data, delete data. Try different configuration variations. And as I said, try possible interruptions. Okay? It should be a creative process. Some things are inherently more fit for exploratory testing than others. And there are things that lend themselves to being pre-designed and pre-scripted, and then there are other things that just really don't. This is an example of an exploratory test charter, and it's kind of a made-up example, but I actually managed a team once where we had to do this. We had a system, and pre-installed on that system was filtering software. And those systems could be configured for different age groups: children, teens, adults, and seniors. And for children and teens, there was filtering that was supposed to prevent them from seeing various kinds of websites. Now, how do you pre-script that? It's very difficult, right? It's a perfect fit for an exploratory test, and that's how we tested it. So when we tested it, at first we found bugs, and I reported the bugs, and the marketing people, who were the ones who gave the thumbs up, thumbs down, fix, don't fix on the bug reports, would go to the company that gave them the filtering software and say, yeah, we need to get this fixed. But it never got fixed. So we decided to do a little group exploratory testing here, culminating in a show and tell. So I went down to the marketing folks and I said, hey, you know how we've been telling you that there are problems with filtering software? There are really problems with filtering software. We'd like to give you a demonstration of that right after lunch. I did it after lunch on purpose for reasons that you'll see in a minute. And so the marketing people were like, oh yeah, okay, we'll come up after lunch. We'll do show and tell. So I go back up into the test lab and I tell my 10 testers, I say, we're going to play a game. Now, first off, anybody who ever has had the phrase hostile work environment occur to them in their mind, you get to take a half day off, paid, okay? You get to go away. Anybody want to leave? And then everybody's like, now they're fascinated, like, what's happening next? I said, no, for those of you who are going to stay, here's what you're going to do. Each of you is going to do exploratory testing all morning, and you are going to find the 10 nastiest websites you can possibly find to get to display on a kids or teens box. No fair having overlap. First one to the website gets to have it for their show and tell, and we're going to try to disgust and horrify the marketing people right after lunch. Bonuses to anybody who can find a website that makes someone throw up in the test lab. And so they went off, and all 10 of them did it. And they each had their top 10. So we had 100 of the nastiest of nasties of the internet up and ready to go. And we brought the marketing people in, and we did our show and tell, and they were horrified. Absolutely horrified. One of them had a daughter who was like 4 years old. I was like, hey, Amy, how do you think your daughter would feel like looking at that image right there? You think that might be a problem? Think that might be irritating? Now, you might think I'm just talking about porn here, but actually some of the nastiest stuff on the internet was like Holocaust denier stuff and morgue pictures and other kinds of stuff that was like, whoa, you know? We could not have done that with pre-designed tests. There's no way. It was an inherently exploratory activity. And that was so soul-shaking to those marketing people. I don't know what they said to that company that sold us the filtering software, but all those bugs that we had been complaining about, gone. The next release, gone. We could not have done that with pre-designed tests. Okay? So there's definitely a place for this. And I can say that I actually got paid for a half a day to manage my test team and make them find porn on the internet. So, you know, got that. I don't have that on my resume, but just remember that in my mind. Any of you familiar with this picture? It's not too far from here, to the east. It's in Moscow, near Red Square, with the little brass ducks and her ducklings. She's got her ducks in a row there. See that? So just to wind up here, and then we'll maybe have some time for a little Q&A. Exploratory testing was not invented in the 90s in Silicon Valley. It was invented who knows where in the depths of time, computer science-wise. I've mentioned a number of myths, and I hope I've burst those myths effectively for you. Those myths will get in the way of you using exploratory testing the way that you should as part of a mix, a blend of strategies that allow us to implement that sort of multiple layers of filtration approach that I was talking about. Time boxing and charters will help you keep this on track, keep your ducks in a row. But ultimately, it's a form of experience-based testing, so use experienced people to do it. Okay? I'm going to put the coordinates up here. So I mentioned our YouTube channel and our website and blog and so forth. So that's all up here if you want to take a picture of that while we go into the Q&A. We have a few minutes left, 3 or 4 minutes for Q&A. Yeah?
Yeah, but there's just one thing that we need to do before we go to a Q&A. Rex Black, ladies and gentlemen.
Thank you very much. You're far too kind. Thank you. Now we're on Slido again.
That's it.
Yeah.
Okay, I was told oh, please fill in the survey. That's not a question. Oh yeah, thank you very much. I was told by the organizers that I'm only supposed to read the ones highlighted in blue for some reason, so I don't get to pick. How to enhance your abilities as an exploratory tester? Is it only practice that matters, or maybe could you recommend a tool or a technique?
So, you know, exploratory testing is experience-based, right? So the more experience you have, the better you're going to be at it. So yes, of course, practicing doing exploratory testing is important, but also learning more about the kind of systems that you're testing, both from a technology and a business sense, is helpful. So one thing I'd recommend is there's this email, regular email you can sign up for. It's called the Risks Digest. About once a week or so this comes out, and it's all full of stories about how software fails. And it's a good way of like getting you to think about, oh, this goes wrong, that goes wrong. And you might say, well, if my software is not in there, what does that mean to me? Well, you know, there's more similarities than differences. I work with clients of all different types of descriptions, and they have more in common than they might imagine. So, you know, studying how software fails is a good idea here. Learning more about how software is built is a great idea. Any of you see the second Terminator movie? Terminator, yeah. So remember that the Terminator had detailed files on human anatomy, right, to make him a more effective killer, right? You should have detailed files on how software is built to make you a more effective bug killer, okay? So, yeah, getting more technical, getting a better understanding of the strengths and weaknesses of software will really help with this.
Question number 2, how long should the usual exploratory testing activities take during, for example, 2 weeks agile sprints? And are there any strict time frames for conducting those types of testing?
I don't know that it's possible to give a hard and fast number of what percentage of the test execution efforts should be exploratory. My usual rule of thumb has been anywhere from like 10 to 25%. An interesting thing that happens is as your test automation gets more successful and a larger and larger percentage of your requirements, your user stories, your design elements, and so forth are being covered by automated tests, the more exploratory testing you need to do, because basically, when you think back of that mix of verification and validation, the more of the verification that's being handled through automation, the more of the validation you need to do, the more of your effort's going to be validation. So, you know, more and more exploratory testing would be important there. I would make sure that the exploratory testing is distributed throughout the entire test execution period, not just something you do at the end. And this is a mistake I've seen made, is that people will go, okay, well, we're going to get all of our pre-designed tests run first, and then whatever time is left over, we're going to use for exploratory testing. But think back to the Microsoft study that I mentioned earlier, whereas the non-overlapping or partially overlapping set of bugs that are found, if you're waiting to do the exploratory testing till the very end, there's going to be a big spike in bugs that you find right at the end of the iteration. And nobody's going to like that. People are going to say, why the hell are we hearing about this for the first time right now, right? So, yeah, don't do it that way. You want to be integrating the exploratory testing throughout that test execution period.
I think we've got just about enough time for one more.
Okay.
So the question is, where did you come across those myths, and what is their origin?
Haha, what's the origin myth of the myths? That's a good one. Meta question there. I guess I bumped into those myths in one form or another, working with clients in a lot of different industries, and each one of those is something that I've heard someone say or is reflective of the way an organization works. And in some cases, I've seen more examples of the myth, in some cases less examples of the myth, but they're all out there in evidence. I don't argue that that's the only set of myths about exploratory testing. There are probably more, some of which I could have thought of if I'd spent more time putting this presentation together, and some of which probably exist and I just haven't seen them because obviously I haven't been everywhere. But you know, I think that they're a good representative set of myths, very common myths, common enough that I've bumped into each of them at least once, and in most cases more than once.
Can I just have my personal question? I mean,
sure.
The testers, are they supposed to do things properly?
Properly?
In general?
Yes, of course.
Do you do things properly? Okay. So I'd like to encourage you to do one thing, but really properly right now. Let us thank Rex Black.
All right, thank you very much. Thank you. Thanks.